Okay. I am Sarala, and I'm the project lead for Identifiers.org, and we are based here at the EMBL-EBI, Cambridge, UK. Oh, there we are. Okay. So, EBI hosts a large number of databases covering wide range of biological entities. It ranges from genes, protein sequences, chemical molecules, to ontologies. So in life sciences, we often use identifiers to identify entities uniquely, and all our databases here at the EBI, we have unique identifiers to identify the individual entities. And they are made actionable by using, by embedding them in a URL. So if you look at the examples I've got here, the orange text is the identifier, and the blue text is the resolver. And it's also common in life sciences to have the same data served from different locations. So, for example, the taxonomy, it's served from NCBI as well as EBI and several other places. So assigning identifiers is a great start, but the way we use it at the moment currently poses some challenges. So the main challenge is the object unification between these different collections. So if you have multiple URLs to represent the same thing, how do we know it is the same thing? And also, when you come to annotate or cite this information, which resource should you be using? And if there's many different locations and one of these locations is down, how do we keep track of these changing URLs and the dead links? So what we have come up with is this compact identifier scheme. The idea is these compact identifiers are globally unique identifiers. So it has a prefix, which indicates the assigning authority, and then we have the accession number, which comes from the database itself. And if you want, when there's multiple resources providing the same content, then you can use the provider code to point to a specific resource. So Identifiers.org system provides a way to create and resolve compact identifiers. We also promote FAIR data, which stands for findable, accessible, interoperable, and reusable. And it is also a community-driven project, which means all our data sets are being requested by the users. So we do spend some time collecting data as well, but mostly we add resources when we have a request from the community, and it is all free to use. So we've been around for over 10 years now. So this year we have been focusing on establishing ourselves as a stable ELIXIR system. So where do we fit in within ELIXIR? We are part of the interoperability platform, and we are a service providing identifier resolution among other services for bioinformatics resources. So what do we have? We have a registry which has over 600 life science data collections. And for each of these collections, we store information about them. So, for example, the description, name, different URI schemes, identifier pattern, and we assign a prefix to each of the collections. The prefix uniquely identify the collections within the registry. And then we store the different resource providers that provide the content. And for each of these resources, we store more information about them: the institution, different formats that the data is supported, the access URL, and we also record whether a particular resource is identified as a primary resource or not. And we also check the uptime. So we ping the data resource to see whether it's up and running, and then we use this information during our resolution time to make sure the user is redirected to a resource that is working. So identifiers.org resolver service stably resolves URLs to current available instance of a data object, and we maintain the URL changes and server downtimes to support this. So, for example, if you use taxonomy:9606 and pass it to identifiers.org resolver, it will probably redirect you to NCBI because NCBI is a primary resource, and it is most of the time it's up and running. And if you want to force the resolver to a specific host, then you need to provide the provider code. So EBI/taxonomy:9606 will take you to ENA at the EBI. It is important to note that we don't store the individual entities. Instead, we maintain up-to-date data access patterns and the relevant metadata of the resource providers. And this is the information we use to point the compact identifier to the right location. Another use case for our compact identifiers is the data citation. So at the moment, when people cite different data sets, it is generally written in words, for example, protein data bank, and then the identifier. So the idea is, as we move forward, to use these compact identifiers that we pass by the resolver and which can resolve. It is also important to note that our infrastructure is really generic, so we can support identifiers beyond life sciences, even though most of the current resources that we have are in life sciences, but we can also resolve to DOIs, ORCIDs, etc. So how do we get the data into our registry? At the moment, we have a form that people can fill in, the resource provider or the user, and this comes to us, and then this information is checked by our curators and added to the registry. So if you don't have your resource in Identifiers.org registry, please go and fill in this form. We also provide advanced search, which enables you to find valid identifiers, the prefixes, and providers, and also validate compact identifiers. We also provide a set of web services which provides programmatic access to the registry and registry's content and our services. So if there is a service that you would like to have and it's not on this list, please do get in touch with us. You can download the registry as an XML dump or as a YAML file. So the YAML file is a subset of the content that's in the registry XML file. You could use, basically the YAML file provides you the information to create the the resolution location if you want to. We also have a SPARQL and virtual SPARQL endpoint. So because we store all the different URI schemes, we are able to convert between different URI schemes in semantic world, the different semantic resources. They use different URI schemes. So running a federated query requires you to do some string manipulation. So if you use our virtual SPARQL endpoint, you can avoid doing that. We are also working with the bioschemas community. The idea is if when the individual data repositories add their metadata in schema.org in their landing pages, then you can use identifiers.org to extract this metadata as well. So at the moment, you can extract the metadata in Reactor, which is in JSON. The metadata is in JSON LD, and it is in the individual pages. Then we could extract it. So the idea, the use case for this service is most of the data resources have their all. So in general, most of the data resources have pointers to other entities, and then they store information about the name, the description, etc. within their content to enable searching. So the idea is if you have this service, you can extract the metadata for your indexing purposes. We also work with N2T.NET Resolver, which is based in the California Digital Library. So the idea is both of our resolvers should be able to resolve these compact identifiers consistently. So you could pass in compact identifiers to identifiers.org or N2T.NET, then you can resolve these compact identifiers. If you want to know more about this harmonization effort, there's a preprint in bioRxiv on this work. And we also have a MOU signed between CDL and EMBL to continue to support this work. So this work was done as part of Force 11 data citation implementation pilot and identifiers within the identifiers work group. So if you're interested, you can join the identifiers.org group in Force 11 for more information. So the main take-home message is annotate and cite your data using actionable compact identifiers. This is all the relevant links to get involved. Please follow us on Twitter, and the code for the resolver and for the web services are available through GitHub. And we do have some discussions going on Google Groups, but not many. So. And I would also like to thank all the people who've been involved in the project, and especially Nick Schutte, who's our main curator. So all the content, he was responsible for all the content, and also the fund desk. Thank you.